And here we're going to look at how we might store the user input. Instead of drawing something new every frame, we're going to store the input incrementally so that we can actually draw some what we're going to call trailing ellipses. So in the same way that we were using our mouse as an input, we're going to do that again, but we're going to store the last few positional values for our mouse so that we can draw circles that are changing in scale as we move back in time. Right? So what we need to do is start to use another type of variable called an array. And an array is a data type that allows us to store multiple pieces of data as opposed to just one. And arrays are used to keep track of objects in a program by assigning them a unique or known address within the collection. So if we were to look at, let's say, this strip of squares, right? This one is stored in the array at location 0. This one's at location 2, right? That's a one-dimensional array. But arrays can have multiple dimensions. So if we have a two-dimensional array, right, we can have a kind of grid or a matrix of options as well, finding the position at 1, 1, right? That gets us over here. All right, so they're really useful whenever we're trying to do multiple kind of multiple actions that are similar or store similar values, but we need to store more than one of them. All right, so in addition to arrays, we need to start to look at how we control the flow of our program, right? And there are a couple of different ways to do that. The kind of main ways are using structures that define repetitive or conditional actions. So we're going to start first by talking about repetition, right? And in the previous exercises, each line of code that we've written has represented a single action, right? In contrast, if we use iterative structures that repeat actions, we can use a structure that is called vernacularly a loop, right? So that it's not just defining one action, but it's defining multiple similar actions, right? And that loop will run until a specific situation or condition has been met. All right, so defining a loop or using iteration can be done in any coding language, and it is going to be achieved through a number of different syntactical versions. So if you're familiar with a little bit of programming, you've done it somewhere else or in processing, you might be familiar with structures that look like the three here we have below. These are just some of the examples where you might start a loop by stating for I or for each, or while some condition is true, do X action. All right, so kind of example of that, right? If we're using a for loop, for an initial condition, until a certain condition is met, do this action, and each time update the condition that we're testing for. All right. So if we were to actually type that out in a particular example, for integer I equal to 0, so that's a starting condition, until I has or while I is less than 150, do this action, and once complete, increment I by 10. So if it started at 0, it will run as 0. Then once we get to the end of the loop, I will increment 10 more units, and we'll say I is 10. It's still less than 150, so we'll move down into the loop, and we'll draw another line that will be from 1020 to 10180. Okay, so let's go ahead and bounce into the next exercise in processing. So this is exercise 4 called storing input, right? So I'm going to save this and do a new sketch. And here we want to draw trailing ellipses or circles from the mouse position. Okay. And there's one more question that came up from the last exercise that we can talk about now while we're doing this exercise. And that question was, how can you keep your sketch a certain size but increase the resolution of the export? So how to increase size when saving the frame, right? So we'll come to that kind of as we go here, because we can copy and paste our save frame from the previous exercise and use it again if we want, and that's when we'll talk about this issue of resolution versus size. Okay, so to write out our pseudocode step by step, right? The first thing we need to do before we even start to write out our setup function is that we want to declare and define some specific variables, right? So the first one we want to do is we want to declare and define how many frames we want to store. Remember that the kind of example image here is that as we move through time, our position is going to be stored. So do we want to store 50 frames of position information or 10 or however many, right? So that's going to be the first step. And then we need to declare an empty array for the X position and the Y position of our mouse. All right, so we'll start to work with arrays. And then once we've done that, which is essentially setting up our global variables, we're then going to develop our setup structure, which, as before, is going to include defining the size, background, etc. Right? And then we'll do our draw structure. And here's where we're going to have some different actions relative to what we had before. So the first thing we're going to do is we're going to fill our array that we've created up here. We're going to fill the arrays using the current position, right? And this has got a little trick to it, which is going to make our life a little bit easier, right? So we'll talk about the trick as we code it. And then what we want to do is, after we have all that positional data, we want to loop through the array of positions, and then we will draw the circle at the current stored position. Okay, great. So let's go ahead and begin our program. The easiest is to start with setup and draw. So let's say that we start with void setup, open our curly brackets, and close our curly brackets. We'll do the same thing for draw. All right, make sure that we enclose all of our pseudocode inside of those curly brackets. All right, then we can go up to the top and start to work with our global variables. And I say global because they can be used anywhere inside the program. They can be used inside of setup, and they can be used inside of draw. And it's important that we declare them out here as opposed to inside here, so that they can be understood as global variables.